Before we can make animated flow fields like this, or even this, here are the things we need to understand. The basic component of a flow field is a simple line. If I slow it down and zoom in, we can see the line grows from a single point until it reaches a certain length. Then it moves around following a path, and eventually the front end stops moving, the back end keeps moving towards it, shrinking the line more and more until the line completely disappears. How do we handle this behavior with code? Let me show you. I want to reveal all the techniques I like to use to draw and animate lines on HTML canvas using plain vanilla JavaScript, little bit of HTML and some CSS. No frameworks and no libraries. Once we fully understand the logic, we will be ready to use this knowledge to create beautiful, complex flow fields. Flow Fields Masterclass is linked in the description down below. Since this is all just very basic coding using simple functions, arrays and loops, the logic we are about to write can be easily converted into any other programming language if that's what you want to do. After a basic setup inside index.html and style CSS, we move into script.js. All of our logic will be written in here. I set up my HTML canvas element, our drawing board, with the usual 2 lines of code. I create a custom variable I call, for example, canvas, and I point it towards the canvas element we created in index.html using its ID. I gave it an ID of canvas1. Then I create a context variable, ctx. I take that canvas variable I just created and I call built-in getContext method on it. This method creates so-called drawing context, which is basically a JavaScript object with all built-in canvas drawing methods and properties. We pass it an argument called context type. We want to work with 2-dimensional rendering context today. Canvas element has 2 independent sizes. Element size, the actual size of the HTML element, and drawing surface size. We want to make sure both of these sizes are set to the same values. I do that by not defining canvas size in CSS and just setting width and height attributes on canvas to the values I want, like this. If you are also declaring canvas size in your CSS file, make sure it's set to the same values to avoid stretched or otherwise distorted drawings. If I console log ctx from line 2, we can see this canvas rendering context object I talked about. Inside, we can see the default canvas settings, such as the current fill style, font. We can see that the default stroke style is set to black here, for example. We can also see all the built-in canvas drawing methods. Today, we will focus on drawing and animating lines, so we will learn everything you need to know about begin path method that comes from here. We also have close path method here, line 2 here, and move to method here. Let's use these methods so we fully understand what they do and how they work. We can draw many different shapes on canvas. 2 basic shapes are circles and rectangles. To draw a rectangle is very simple. We can take context we defined on line 2. We know it holds a reference to the object that contains all canvas drawing methods. And from there, we call built-in fill rectangle method. Fill rectangle expects coordinates from which we will start drawing the rectangle, the top left corner of the rectangle. X coordinate, the distance of the top left corner of the rectangle from the left edge of canvas will be 100 pixels. Y coordinate, the distance from the top will also be 100 pixels. The width of the rectangle will be 50 pixels and height will be 150. I can change the width to 200 pixels, vertical Y coordinate to 150 pixels. I think you get the idea. By default, the fill of the shapes drawn on canvas is set to black. I can use fill style property to override that default value, and I can set it to something else. Let's try red. We can also call built-in stroke rectangle method, which will just outline the shape. By default, it will be black line with 1 pixel width. I can change that using line width property. Let's try 10 pixels. And I can use stroke style to change the color of all lines drawn on canvas, for example blue. So these are the very basics of drawing shapes on canvas. Today we will focus on drawing lines. They work a little bit different than rectangles. We need to start by calling built-in begin path method. This method will start a new path and it will also automatically close all existing paths if there are any. This is important because this way you can draw each line in a different color, and without begin path, all your lines will automatically join into one massive shape, which is not what we want today. Right now, we just want to draw a simple line. We start by using built-in move to method. This method will create a new subpath. For our intents and purposes, let's think about move to method as a way to set starting x and y coordinates of our line. Then we will use line to method, which will create a straight line from the subpath from the point defined in move to the coordinates we pass to line 2. Let's think about it for now that line to method will represent the ending x and y coordinates of our line. Move to and line to methods just define the path, they don't directly render anything. To draw the path onto canvas, we have to use built-in stroke method. Now we are drawing a line from coordinates 300, 300 to coordinates 350, 400. We can change these values to change where our line starts and where it ends. I can delete the rectangle now. In this area, I want to define global canvas settings. Line width will be 10 pixels or 100. I move the coordinates. We have many other properties we can use here. You can see all of them if you console log ctx from line 2 as we did before. For example, look what happens when I set line cap property to round. I set stroke style to magenta, line width to 10. We can also chain multiple line to methods like this. Each new line to method will define another point in the shape that will be connected with our subpath and then stroked. This is the main concept of animation we are doing today. We will have a line that starts somewhere. Then we will have many line to calls to define points along that path, and similar to the classic game of Snake, we will animate this by always adding a new line segment to the start and removing the last segment, making it look like the line is scrolling over the screen. I add a new line, I add one more, I remove the oldest segment, I add another new line. We will automate this and we will play with the coordinates we pass to these lines to create interesting movement patterns. Once you understand this concept, we will use it to build beautiful flow fields like this one in an advanced class. It might be easier than you think to make the lines flow around images or letters. Now that we understand the concept, let's scale it up. I want to create a custom JavaScript class that will draw and animate lines for me. I want to animate many lines at the same time, so using a class is ideal here. Class constructor is a special method to create an instance of a class. When we call it with the new keyword later, class constructor will create one new blank JavaScript object and it will set its properties and values based on the blueprint inside. So let's define that blueprint. I want to start very simple and we will optimize the code after to make sure it's absolutely clear what's going on. Each line object will have starting x and y coordinates, so a custom property I call, for example, startx, will be a random point between 0 and canvas width horizontally. Starting vertical coordinate of each line will be a random value between 0 and canvas height vertically. So when we combine these random x and y coordinates, it will give us a point somewhere within the canvas area. I want to do the same thing for ending x and y coordinates like this. So when a new line object is created, it gets randomly assigned start point and end point. Let's give it a custom draw method to draw a line between these 2 points. I call begin path first. Move to method to define starting x and y coordinates of the line. Line to method to define ending x and y coordinates of the line. And we call stroke to actually render that path on canvas. We have a class, our blueprint is ready. How do we actually use it to create one line object? I create a constant variable I call line1. I set it equal to new line, like this, The new keyword will look for a class with this name and it will trigger its class constructor. Class constructor will create one new blank JavaScript object and it will assign it values and properties based on the blueprint inside. That object will be saved in this custom line1 variable. Since this object was created using the line class, it has access to this public draw method and I can call it like this, line1.draw. Random starting and ending coordinates were calculated and a line was drawn. Perfect. Up on line 7, I'm setting line width to 10 pixels, but maybe I want each line created by the class to have a random width within a predefined range. I created this .linewidth property and it will be a random value between 1 and 16 pixels. I will wrap it in method floor so we don't get sub-pixel values. It's a good habit to do that for everything we draw on canvas whenever possible. I could have also done it for x and y coordinates. I take ctx from line 2, .linewidth, and I set it to this randomized line width value. Now, every time I refresh my browser window, a line with randomized position and randomized line width will be drawn. We are doing something that's considered a bad practice here. I defined canvas variable on line 1 and I'm using that same variable directly inside my class. I do the same with ctx variable. The code will work, but if you are writing object-oriented code, the goal is to keep your classes independent of their lexical environment, independent of the code that's outside the class itself. Right now, this class will only work if canvas and ctx variables are defined up here. The right way to do this is to convert these outside variables into class properties. That way, they will be passed to the class constructor here when the class is created, and they can come from anywhere in our codebase, making our class more self-contained and reusable. You often ask me about why I do this in the comments, so I hope this explains it. Line class constructor will expect canvas as an argument. Inside, I convert that argument into a class property. I'm saying take canvas variable that was passed here and convert it into canvas property on this instance of line class you are creating right now. Then we can use this.canvas from line 12 here instead of directly pulling the variable from line 1. To make all this work, I know that line class constructor expects canvas as an argument, so I take canvas variable from line 1 and I pass it as an argument here, when we create an instance of that class with the new keyword. Perfect. We are also directly pulling ctx variable from line 2 into our class here. So our public draw method will expect context as an argument and it will be used here. Then we take ctx variable from line 2 and we pass it to draw method down here when we call it. That ctx will get converted into context here. So this is how you make classes more self-enclosed and less dependent on the surrounding code outside that class. We are defining stroke style up on line 8, but maybe I want the color of the lines to be randomized as well. In that case, I have to define stroke style inside draw method here. I set it to red just to test it, if it's working. I want to assign a random color every time we create a new line. The easiest way to do that is by using HSL color declaration. On the web, we can define colors in many different ways. You have your standard RGB and hex color declarations that everyone is familiar with. We can also use HSL color declaration, hue, saturation, lightness. The first argument here, hue, will represent a degree on the color wheel from 0 to 360. Saturation will be 100%, we want full colors. Lightness will be 50%, we want a color not affected by light or dark. 0 degrees on the color wheel is red, as you can see. 120 is green, 240 is blue, 360 we cycle back to red again. As we increase the hue, we travel over all the colors in between. If we go any higher than 360, we just cycle from the beginning, from the red color again. HSL color declaration is structured in a way that makes it very easy to randomize colors or to dynamically cycle through the color spectrum. I create a custom class property I call this.hue. It will be a random value between 0 and 360. And I want only integers, so method floor. We will make stroke style dynamic by replacing hard-coded hue value with this randomized variable like this. And that's it. Every time I refresh the page, we randomly calculate a different color. As we said, JavaScript class is a blueprint. We can use it to create many similar objects. So why are we creating only one randomized line? Let's create many more. At this point, it's very easy. First, I create a variable called lines array. This will be an array to hold all our line objects in one place. Now I can create a for loop. That for loop will run, for example, 10 times. Every time it runs, I take lines array and I call built-in array push method. Push method will take whatever we pass to it as an argument and it will push it to the end of the array. I will pass it new line, and on line 11 I can see that line class constructor expects canvas as an argument, so I pass it canvas variable from line 1. I delete this code and I console log lines array. As expected, it contains 10 line objects created using our custom line class. I open one and I inspect it to make sure all the properties have values. I want to check that nothing is undefined, which would be a signal of a problem. All is good here. I can also create number of lines variable, and I set it to 50. I use it here in the for loop. In the console I can see that lines array now contains 50 line objects with randomized positions, line width and colors. How do we draw them? Since we are holding all line objects inside lines array, we can simply call built-in array for each method on it. For each method will call a provided callback function once for each array element. So inside, for each line object in the array, I want to call its associated draw method we defined on line 20. If you are wondering where this word object is coming from, it's just a random word I chose to use. We are basically assigning each object in the array a variable name that will be used to refer to that object inside this for each method. That variable name can be anything as long as we keep referring to it that way everywhere inside this callback method. I can also call it line, for example. So for each line object inside lines array, call its draw method. On line 20, I can see that draw method expects context as an argument, so I pass it ctx variable we defined on line 2. We are drawing 50 lines on canvas. Each one has randomized starting and ending coordinates, randomized width and color. You can refresh the page to generate a new set of random values and draw them on canvas. Congratulations if this is your first creative coding project. This is a very simple form of procedurally generated art, so-called generative art. Generative art is a collaboration between a human and a machine. Rules and scope of this artwork are decided by us, the human, but some of the features, in this case colors and positions, are randomly decided by a computer. There are of course much more advanced forms of generative art, and I made many classes where we explore that in different ways. Let's see where we can take this one. Let's animate it. Click the like if you are getting any value. For clarity, I will go back to one line so we can better see what's happening. As we said in the beginning, I want to have a line made out of multiple segments. We will be adding new segments and removing old ones to make it look as if it's crawling around, like the classic snake game, kind of. I need to make some changes in the line class to achieve that. We will need only one set of x and y coordinates like this. These coordinates will update for every tick of animation loop, and we will add and hold a certain number of positions in a history array that I define here. First, it will be a simple object with x and y property equal to this.x and this.y we just randomized here. This.history is an object now, but it will be an array where each element in that array is an object like this with x and y coordinate. Move2 method will define the starting x and y coordinate of our path, and it will be this.history array index 0, which will be an object like this, and we access its x coordinate and also its y coordinate. Let's say I will keep 10 objects inside history array. Each one has its x and y position value. Here I want to cycle through however many positions we hold in history array, and I want to connect them with a line. So I create a for loop which will run as many times depending on the length of this .history array from line 15. And each time it runs, it will take object which will look like this, add that index in the array, and it will pass its x and y coordinates to line2 method. So we have move2 method to set starting x and y position of the line, and then we cycle through all other positions and we connect them with a line. Then we call stroke to render that multi-segmented path on canvas. We don't have animation loop yet, so I will create another for loop that will just simply run 3 times and create 3 randomized x and y positions. I need to make sure this .history up here is actually an array. At first, it will contain just one element with an index of 0. It will be this object that has x and y properties set to this.x and this.y coordinates. Here I run a for loop 3 times. Each time it runs, I create new random x and y position. I take this .history array and I push another object with these new x and y properties in there. Careful about the brackets here. Nice. Every time I refresh the browser window, we draw a new multi-segment line, starting x and y coordinates, and for loop that runs 1, 2, 3 times, each time creating a line segment, a subpath. I can make the for loop run 30 times if I want to, which will create much more complex shape. I hope it's clear now how the concept of history array works. Now we take it one step further to animate it. I create a custom function I call, for example, animate. Inside we will draw a line. We will update it, and then we call built-in request animation frame, which tells the browser we want to perform an animation. This will make the browser call a function we specify before the next repaint. In practice, this means I simply pass it the name of its parent function, animate runs, it does something, and then request animation frame will call animate again, creating an endless repeating animation loop. Request animation frame method sits on the window object, but it can be called directly like this. So here we define animate. I need to call it to start the first animation loop. I put a console log inside that says animating, just to check the loop is actually running. Yes, I delete it. I want to put our draw code inside, like this. This is just creating an endlessly growing line. We can temporarily comment out line 47 if your computer struggles with this. We will fix it in a second. I want to delete old paint between every animation frame, so I call built-in clear rectangle method. I want to clear the entire canvas from coordinates 0, 0 to canvas width, canvas height. Okay, I comment this out because we are adding 30 line segments over and over into history array here on line 24, creating an endlessly growing array. I create an update method on the line class. For every animation frame, every time update method runs, I want to add one new segment to our line. I will delete all of this. I uncomment line 47, and for each tick of animation, I want to call draw method on every object inside the lines array. Currently, we have just one object in there. I also want to call the update method we just defined. Now you can see line gets drawn segment by segment. It doesn't make sense to cycle through the same array twice here, so instead I call draw and update in the same callback function. Careful about the brackets here. Easy to make a mistake and get an error. Nice. I don't want to be drawing a path with an endlessly increasing amount of points. I want to have a certain max length, and when that is reached, we will remove the oldest segment and we add a new one. Let's say I want the path to be 10 segments long. Inside update method, as I add a new segment, I check if the length of history array is more than max length. If it is more than 10, we will use built-in array_shift method. Array_shift method removes the first element from the array. Because we are using push method to add a new segment, push method adds new element to the end of the array. Shift method will remove the oldest segment for us from the beginning of the array. And here we reach the second step in our procedural line art. What do you think about this? It's chaos, but with rules. We can add as many lines as we want. They all have randomized width and color because of the logic we wrote in the beginning. We are just randomly picking points inside Canvas. What if we want some sense of continuous motion? We want the updated position of the next segment to have some relation to the position of the previous segment. This is getting us one step closer to an actual flow field. Hope you're getting some value. Let's explore motion now. I will think of our line as a particle. Its first segment is moving along the canvas in a certain speed and direction, and the other segments follow. I give each line speed x, horizontal speed, and speed y, vertical speed. We will start from a random point somewhere within canvas area, and every time we call update method, we increase the current x position by the value of speed x and vertical y position by the value of speed y. Inside animation loop, I will uncomment draw and update to see what we just did. Okay, I create 20 lines. Yes, this is what's happening. I'm going for lightning effect. I want a rainbow lightning storm. Every time we update horizontal position by speed x of 10 pixels, we will on top of that add a random value between 0 and 10 and 50. What about a random value between minus 25 and plus 25 horizontally and the same vertically? Interesting. When I refresh my page, I get a set of very short lightning bolts. If I want them to go more from the top to bottom, maybe horizontal speed will be only plus 2 and vertical speed 15 or 4. 6. I would like the animation to play out and then reset. I could, for example, check if all segments left the canvas area, or I can give each line a timer. Let's say each line has a lifespan of max length from line 18 times 10. Each line will move around for 100 animation frames. Inside update method, I will increase timer by 1 for every animation frame. How do I do this? If timer is less than lifespan, we animate the line. I also need to define this .timer in the class constructor up here, and I initially set it to 0. When the timer is more than lifespan, we are still drawing the lines, but we are no longer adding and removing segments, so it looks like they froze in space. At that point, I want to start removing segments one by one until the line disappears. So else, and here I will again call shift on the history array. Bear with me a second, I need to work out the logic here. We need to make sure that there is always at least one element in the array, else if this.history.length is less or equal than 1, call reset method. We will define reset method now. Will this work? Timer is increasing. As long as the timer is less than lifespan, add and remove positions, making the line crawl around. If the length is less or equal to 1, reset it. Else, meaning the timer is more than lifespan, but length is not yet less or equal to 1, keep removing one segment at a time. I think this should work. Now I need to define the reset method that will just set the line back to its initial state so that we can animate it again. We will need to reset x and y position, and we will add that starting position inside history array. We will also reset timer back to 0 so that it can count again. I'm getting a console error. Probably you noticed this before. I need to call shift to remove the first segment from the array on the actual history array. Like this. Yes, this is what I wanted. Lines move around for 100 animation frames and then they reset. They all reset at the same time because we hard-coded max length to be the same value for all of them. I set it to a random value between 10 and 160 segments. Now we are getting some real sense of motion. I can also randomize speed x, let's say a random value between minus 2.5 and plus 2.5. Speed y will be 6, speed y 10, maybe here I should do a random value between minus 0.5 and plus 0.5, speed y 5, 7. I can also play with the random range here and here. Generating random numbers like this for each animation frame is very performance expensive, just so you know. But since we don't have thousands of lines, most computers probably won't even notice. Reducing how many times your codebase calls math.random per animation frame will massively increase performance of your effects. I set lifespan to max length times 3. You can see that we have a line that starts from one segment, it grows until it reaches max length, then it crawls around to a maximum 3 times its max length. At that point, it no longer grows, it shrinks from the last segment from the end, and then it disappears and resets. This type of line motion is exactly what you need to create flow fields. Now you know one way how to implement it. I create 100 lines. This is my version of procedurally generated rainbow lightning storm. If you are a beginner and you followed all the way here, you are now a creative coder with a knowledge of HTML Canvas. Congratulations! Feel free to add this project to your online resume. HTML Canvas offers so many different built-in tools that allow us to modify our animations. We just built the rainbow lightning storm effect. The lines we are drawing on canvas are just shapes. Let me show you 4 very different ways how you can enhance the fill and stroke of your shapes using gradients, images, and shadows. HTML Canvas offers 2 methods to draw gradients. We can use create linear gradient method. It's very simple to use. Let me show you. It creates a gradient along a line connecting 2 given sets of coordinates. The first 2 arguments we pass to it are x and y coordinates of the start point. I want my gradient to start at coordinates 0, 0, and I want the end point to be at coordinates canvas width, canvas height. We drew an invisible line from here to here. Gradient will be drawn along this line. To work with gradients, it helps to save it in a variable. I call it, for example, gradient1. Then I take that variable and I call built-in addColorStop method on it. Here we define offset and color. So at offset 0, in the beginning of the gradient, I want to start from pink. I copy this line a few times. Let's start at offset 0.2 actually. 0.3 will be red, 0.4 is orange, 0.5 is yellow, 0.6 will be green, 0.7 turquoise, 0.8 is violet. That's enough, I think. I take this stroke style declaration and I put it here after we defined the gradient. And I will set it to the variable that holds our newly defined linear gradient. Notice there are no quotes, just the variable name like this. I also need to comment out line 33 so that our gradient gets applied. As you can see, we are drawing a linear gradient from coordinates 0, 0 to canvas width, canvas height. I create 200 lines. This is a very different version of Rainbow Lightning Storm, isn't it? I copy this line of code. I will call it gradient2. We also have create radial gradient method. This one expects at least 6 arguments. X and y of the center point of the inner start circle and its radius. I want the circle center point to be in the middle of canvas, so canvas width times 0.5, canvas height times 0.5, and radius will be 30 pixels. The end circle will be also starting in the middle of canvas with a radius of 200. I give it 2 color stops just to show you what that looks like. I think you already understand this concept anyway. At 0.4 offset we will have green. From 0.6 it will be blue. Then I set stroke style to gradient 2 here. I can change the radius value. I can add color stop here. So this is how you use linear and radial gradient. Same as we are filling our shapes with gradients, we can fill them with a pattern. That pattern can be something we draw on an off-screen canvas, but we can also use an image. In index.html, I create an img element. I give it an ID of pattern image. As a source, I would normally use a path towards that image file, but that would give us problems if we run our code locally just from a folder without using a server. To avoid any cross-origin resource sharing issues, I will turn the actual image into base64 code, and I will make that code part of our index.html file. When I do that, the image will be considered same origin in all scenarios, so I don't have to deal with anything server-side in this course. I want to focus on front-end web development. I prepared an image that you can download in the resources section below. I made it the same size as our canvas. You can also use your own image if you want. I can use JavaScript to turn image into base64 data string by drawing it on canvas and using toDataURL built-in method. But for simplicity, I will use a website to do that for me. There are many websites that can turn images into code in seconds for us. I just go to Google and I search for PNG to base64 phrase. I will choose this link, onlinepngtools.com. I drag and drop the image I want to convert here, and it generates a data string for me. We have to make sure that the string starts with base64. If it doesn't for you, click this checkbox to get the correct format. I copy this entire code block. It's a lot of code depending on how big the image you are using is. I paste it here inside source argument, inside src. In Visual Studio Code, I can go to View, Word Wrap to put this extremely long line of code onto one line, making it easier to navigate in this code file. I go to Style CSS. Actually, I save the changes in index.html, and you can see that we are drawing the image on the web page without needing the actual image file. The code we just generated replaces the image file completely, and it contains all the pixel information about that image. I hide the image with CSS using its ID, display none. Okay, we have an image we can use. So in this area, we defined gradients. Here, we will create a canvas pattern. It's also very easy. I will need a reference to that img element we just created in index.html. I create a variable I call pattern image, and I point JavaScript towards the img element using its ID. Another variable I call pattern1 is equal to ctx dot, and here we use built-in createPattern method. This method works very similar to the two methods we used to create gradients. It takes two arguments, image and repetition, and we can then use it as fill style or stroke style to fill our shapes with that image. Let me show you what that looks like. Image to draw will be pattern image we just created, and repetition rule will be no repeat. Now I simply set stroke style to pattern1, and here we go. You can see that our lines are now filled with an image. This technique can be used as a way to reveal an image. For example, depending on what kind of application or effect you are building. We can also use a seamless tile as an image to create a repeating pattern, which is probably what this method was designed to do as the main purpose. I can use wider lines to see more of the image, for example. I like to use canvas shadows to give my shapes a subtle 3D effect. I set shadow offset to 2 pixels. This will define the distance between shadow and the shape horizontally. Shadow offset Y, vertical distance, will also be 2 pixels. These can be positive or negative values, by the way, depending on which side relative to the shape you want the shadow to be. Shadow color will be white. This will give us this interesting cracks effect. I reduce the number of lines, shadow color black, I can go back to gradient 1, the linear gradient. Now we can better see what the shadow is doing and how it highlights the edges. If you have any performance issues and FPS drops, the quickest way to fix it is to reduce the number of lines you are animating, and you can also disable these shadows. I set line width to a smaller value. Our rainbow lightning storm can take many forms, and I think you have plenty of tools now to adjust it and make it your own. Let's do something completely different with this now. How about instead of lightning, I want spirals. Let's talk about trigonometry. As always, you might want to create a copy of your code to save this effect for a future reference. We will make radical changes to the code now, and we will transform it to a completely different generative art piece. Trigonometry is all about angles. I want each line object to have its own angle property, so I define it here. For every animation frame, I will be endlessly increasing that angle value by 0.1. This value will represent radians. So instead of doing this lightning effect here, I will increase x by math.sine and I pass it this ever-increasing angle value. This will create left and right horizontal motion like this. Passing an ever-increasing value to math.sine will just map these values along a sine wave. What if I want the waves to go further left and right? I create a property called this.curve and I set it to 30. By default, math.sine is cycling between -1 and +1. If I multiply that value by this.curve, we increase that range. And this is the result. I want smooth lines, so I remove this part of code here. Try to use different value for the curve if you need more clarity on how this value affects the motion of our lines. What if I want the curve to start at a very small value and gradually increase? Starting curve will be 0.1 and VC, the speed at which it will be increasing, will be 0.25. Inside update method, for every animation frame, I want to increase curve by VC, like this. And when lines restart, I want the angle and the curve to go back to 0. Interesting effect. We can do so many different things with it now. What if I also increase vertical y coordinate by sine of the angle times curve? We get this strange back and forth motion, but if I use cosine instead, sine and cosine will work together to map a path along a radius of a circle. And because curve is increasing as animation runs, we don't get circle, we actually get spirals. I set VC, velocity of curve, to a much smaller value. Now we are drawing spirals like this. I can also make it a random value between -0.2 and +0.2. Minus values will move in the opposite direction. Maybe I also want to randomize how fast the angle increases. VA, velocity of angle, will be a random value between -0.25 and +0.25. Then I use it here instead of the hard-coded value. The speed at which the angle is increasing will affect how compact the curve is, how fast it spreads out. This is symmetry. I want to add some chaos now. For this simple art project, I imagine someone is drawing these beautiful symmetrical spirals, but at a certain point they get angry and they start scribbling randomly and they break the spiral shape. Let's say if the timer is more than half of the lifespan, the second half of line's life cycle, start multiplying VA by -1, switching it to the opposite value each time a new animation frame ticks, each time a new segment is drawn. This will break the spiral shape like this. We have a path that starts as a spiral and then it turns into a broken line. I wanted the line to be more and more broken. We need more chaos at the end. Yes. Let's change this to 0.9. Most of the time it will be symmetry, last 10% will be chaos. Because we are modifying VA value and we are not bringing it back to its original range, lines stop making spirals the way they should. As the lines reset, we need to be also reset in VA value. I copy line 48 and I paste it down here inside the reset method. Nice, we start with symmetry and we end in chaos. Exactly like me on a Saturday night. We are constantly calculating lifespan times 0.9 because this calculation happens so often. To make it easier for JavaScript to run this code and help the performance a little bit, we can pre-calculate this just once in the class constructor, and we will then use that pre-calculated value here. I will call it, for example, this.breakpoint, and it will be lifespan times 0.85. Then I can use this.breakpoint here, and instead of calculating this 60 times per second for every line object, now we are just calculating it once for each line at the point where each line object gets created using the class constructor. I make the lines wider. I set canvas background to black. Yes, this is the effect I wanted. I comment out stroke style on line 54. Now the stroke is black, so we don't see anything. I can give it white color. Now you can see again how the shadows give it a very subtle 3D effect. I set number of lines to 150. Be careful here, it might be too much for all the computers and you might get lower FPS. I do 100. I'm just experimenting now. I can set stroke style to linear gradient we defined on line 15, just to see what that looks like. How about I use radial gradient? For this one, I should definitely choose different colors to make it look nice. I can also use the image pattern here again. Interesting. Have you seen this create pattern method being used before, or is this your first time? Now you have all the tools you need to create fully animated, beautiful flow fields. Check out the links in the description and join me in an advanced class where we used the techniques we learned today to create more generative art. Hope you got some value today. Click like if you did. See you soon.